I want you to cast your mind back to high school physics for a second.
Oh, boy.
Yeah, picture that classic science classroom, right? You probably remember learning about electricity and magnetism and, the fundamental building blocks of matter.
Right, the classic Bohr model.
Exactly. Your teacher likely stood up there and told you all about protons and electrons, and they probably drew these like little perfect spheres on the whiteboard.
Usually with little plus and minus signs inside them.
Yes. The protons had a little plus sign painted on them in red, and the electrons had a little minus sign painted in blue. And the lesson we all walked away with was incredibly simple.
That charge is a physical thing.
Right. It's a physical property. It's this invisible substance or, I don't know, a microscopic fluid that a particle just carries around in its little backpack.
It is deeply comforting to think of it that way, honestly.
Yeah, I mean, if you break your arm, the X-ray shows the physical break, right?
Yeah.
You look at an electron, the math shows the physical negative charge. It's binary. It's clean.
We humans love it when things are visible, when they can be neatly categorized as stuff. Our brains are literally evolved to deal with objects we can touch and hold.
Right.
So naturally, when early physicists started trying to explain electricity, they pictured it as a fluid flowing from one place to another.
Like water in a pipe.
Exactly. And even as quantum mechanics developed, we stubbornly held on to that intuition. We still like to think of charge as, well, what physicists call a primitive quantity.
A foundational building block.
Right. The assumption has always been that charge is just there. Unbreakable, irreducible, and intrinsic.
Exactly.
Right.
We treat it like mass or volume in everyday life. But what if everything we were taught to visualize about that little minus sign on the whiteboard was completely upside down?
That is the big question.
What if charge isn't a substance at all? What if it's not a thing a particle carries, but simply the direction it happens to be facing?
Which is a completely paradigm-shifting concept. I mean, it completely shatters that high school whiteboard model.
It really does.
When you step into the world of George James Dukas in this entirely new framework, suddenly that classical X-ray machine is broken. We are looking at a diagnostic landscape for reality itself that is, well, honestly, it's murky until you learn to see the geometry.
For sure.
The standard models we've relied on for decades suddenly look like child's play compared to the underlying architecture he's proposing.
It is the absolute definition of diagnostic muddy waters, at least at first glance. And that is exactly what we're plunging into today for you.
A very deep dive.
Yep, we have a single monumental source for our deep dive today. It's George James Dukas's 2025 paper on transdimensional unified field theory, or TDUFT.
Which is a mouthful.
It is. Specifically, though, we are going to be focusing on his groundbreaking work regarding the mechanism of charge. And I have to say, reading this paper felt like trying to learn a completely new language.
It essentially is a new language. This isn't just a slight revision of the standard model of particle physics.
Right, he's not just tweaking things.
No, he's not just adding a new particle to the zoo or tweaking an equation. This is a foundational teardown and rebuild of how we understand the fabric of reality.
Yeah.
Dukas is asking us to completely unlearn the idea of charge as a primitive quantity. He's demanding that we stop looking for stuff and start looking for structure.
Okay, let's unpack this.
Yeah.
Because our mission today is incredibly ambitious.
Sure.
We are going to guide you through this entirely new way to understand the universe. We are going to take that little minus sign on the electron, completely strip away the idea of it being a physical substance, and rebuild it from the ground up.
Rebuild it as a geometric orientation.
Exactly. And what Dukas calls a fractal field. By the end of this deep dive, the goal is to give you a profound aha moment about why matter exists.
Why you and I don't instantly dissolve into radiation.
Yeah, that's a good one to know. Why electrons are incredibly stable and where the concept of mass actually comes from.
It is quite the intellectual journey. We're moving from treating particles like isolated tiny billiard balls bouncing around in an empty void to treating them as complex dynamic resonances.
Right.
Resonances within a vast, interconnected, multidimensional architecture.
So to start, we really have to tackle this illusion of substance. In TDUFT, charge is described as an emergent property.
Right. It's not there.
It's a state of orientation within a very specific geometric lattice. And Dukas calls this the phi-psi fractal field. For someone who doesn't spend their time doing advanced vector calculus, what exactly are we looking at here?
Well, to visualize this, you have to imagine reality not as an empty room where objects happen to exist, but as a structured lattice.
Okay.
Think of a crystalline structure, or like a 3D grid that permeates everything. a fractal geometry that underpins the entirety of existence.
Sounds intense.
And this field isn't passive either. It has two fundamental built-in behaviors or branches that govern how it behaves. First, there is the phi branch.
Spelled P-H-I for anyone trying to picture the Greek letter.
Correct. The phi branch is characterized fundamentally by expansion, by an outward-reaching curvature.
Okay, phi is outward.
Yeah. And then, acting in opposition, there is the psi branch, PSI, which is the exact opposite. It is characterized by contraction, by an inward pulling curvature.
So phi is outward, psi is inward, sort of like a cosmic lung breathing in and out.
That's a decent conceptual starting point, yeah. But we have to be careful not to oversimplify it into just a flat space expanding and contracting.
Oh, right.
This field is incredibly structured into what Dukas defines as the dimensional ladder, or the D ladder. You can think of it as a sequence of dimensional tiers.
Like floors in a skyscraper.
Sort of, but infinitely more complex. We start at D0, which is the most foundational base dimension. It's the absolute ground floor of reality.
Right, T0 is the ground floor.
Right. From there, you step up to D1, then D2, D3, and so on, building up the dimensions. But here is the critical part that separates this from classical physics. This ladder is not neutral. It's not a blank staircase where every step is identical. The steps themselves are inherently polarized by those phi and psi behaviors we just talked about.
So the staircase itself has a built-in bias. It wants you to move a certain way.
Exactly. The psi-dominant direction of this ladder, the inward contracting geometry, is intrinsically tied to what we historically call negative polarity.
Oh, I see.
Yeah, and the phi-dominant direction, the expanding outward geometry, is tied to what we call positive polarity. The space itself dictates the polarity.
Okay, I was trying to digest this concept earlier, trying to map it to something familiar, and I came up with an analogy. I want to test this on you.
Go for it.
So instead of thinking of an electron as a physical ball painted blue to represent negative, and a positron as a physical ball painted red to represent positive, we should think of them as identical cars.
Okay.
Just perfectly identical, featureless cars driving on a highly polarized, specialized highway system.
Okay, I'm tracking with the cars. Go on.
If the car merges and happens to drive inward down the psi lane of this dimensional highway, the physical constraints and the environment of that specific lane force the car to behave in one particular way.
Right.
The physics of that lane make it act like what we traditionally call a negative charge. But if that exact same featureless car merges outward and drives down the phi lane, the environment of that lane makes it behave completely differently. It acts positive.
I see where you're going with this.
Yeah, so the car didn't change its paint job, it didn't swap engines. The lane it chose entirely dictated its identity to the outside observer.
What's fascinating here is that your analogy actually captures the functional essence of the theory very well, but I do need to gently correct a fundamental assumption in your visual.
Oh, okay. Lay it on me.
It's not just moving along a lane like a separate car on a flat road. That implies the particle is a distinct object traveling through the field. In TDUFT, the particle isn't separate from the lane. It is a vibration of the lane.
Oh, interesting. So it's not a car on the road, it's a ripple in the asphalt.
Precisely. It's about how the fundamental oscillation, the resonance of the particle itself, actually aligns with the very geometry of those dimensions.
That is a big distinction.
It is. But your core insight is absolutely spot on. The polarity isn't a substance hidden inside the car. The polarity is entirely derived from the dimensional direction the resonance takes.
It's the architecture of the field dictating the behavior of the ripple. That completely reframes how I look at chemistry and physics.
It's a huge shift.
Okay, so if charge is just a direction in this fractal field, the obvious next mystery to solve is, well, how does a particle actually choose its direction? What is steering this ripple?
And to answer that, we have to look at the mathematical heart of Dukas's paper, which is the charge triad.
The charge triad.
Right. Dukas proposes that charge is essentially a composite orientation made up of three distinct axes. He writes the formula for charge as Q equals S sub D times D sub plus minus times V sub d.
Okay, let's slow down and break that formula apart for the listener. Q is obviously charge, and it equals three things multiplied together.
Yes. Let's look at the first two axes first. The spin director, which is the S sub D, and dimensional polarity, which is the D sub plus minus.
Let's start with the spin director, because I feel like the name is a bit of a trap.
It really is.
Yeah, when anyone with a passing interest in physics hears the word spin, we immediately think of classical quantum spin. We picture a little top spinning on a table, maybe spinning clockwise or counterclockwise.
Which is incredibly misleading.
And frankly, quantum spin has always bothered me because physicists will tell you an electron has to spin 720 degrees just to look exactly the same as it did when it started, which makes zero logical sense to a normal person.
You're touching on a very real frustration in modern physics. Classical quantum spin is a notoriously confusing mathematical abstraction.
Seriously.
It behaves like angular momentum, but it's not actually a physical object spinning. Dukas is very explicit here. The spin director in his theory is not that classical quantum spin. You have to discard that mental image of the spinning top completely.
Gladly. Throwing it out right now. So what is it?
The spin director is a dimensional orientation operator. Think of it quite literally as the compass of the particle.
The compass.
Yes. It dictates the fundamental direction, the resonance points within that D ladder we established.
The dimensional compass. I really like that term. It grounds it in something I can visualize.
It is a compass.
Yeah.
And it determines a profoundly important geometric action. It decides whether the resonance can lift from its base resting state at dimension 0.
D0.
Right, from D0 up into dimension 2, which is D2.
Wait. I have to challenge this right here because this sounds like a massive mathematical loophole.
How so?
Are you saying that at D0, at the absolute base level of reality, charge is completely invisible? That it just doesn't exist until the particle physically or geometrically elevates to D2?
That's the idea, yeah.
How can something exist but not be detectable?
What's fascinating here is that that is exactly what the math demands, and it actually solves a lot of problems. Yeah, at D0, the electron exists as what the paper calls a neutral rest resonance. It is completely hidden inside the phi-psi lattice.
So it has no charge?
It has no visible charge, no branch dominance, no dimensional curvature that our instruments can interact with. It is just sitting there, existing as pure geometric potential.
Wow. It's like a spy in deep cover. You have absolutely no idea what side they are on, what agency they work for, until they are actively called upon to do a mission. They are perfectly camouflaged in the crowd.
That is an excellent way to put it. The transition, this geometric lift from D0 to D2, is the activation code for the spy.
Okay, I like that.
D2 is the charged tier of the universe. When the spin director, the compass, allows that lift to happen, it physically forces the resonance to align with either the phi branch or the psi branch.
And that alignment is what exposes the second axis of our triad, dimensional polarity.
Exactly, the built-in bias of the map we talked about earlier.
Right. So to summarize this beautifully elegant mechanism, charge is not created out of nothing during this lift. It's revealed by the orientation.
It's revealed, exactly.
Wow. The compass points the way, and stepping onto the map at D2 exposes the terrain. The spy takes out their gadget, and suddenly you know they are working for MI6.
Exactly. The spin director is the compass, and dimensional polarity is the map.
Okay, but a compass and a map don't actually get you anywhere on their own. You can hold a compass and look at a map all day, but if you don't move your feet, you're just standing in the woods.
True.
Something has to propel this resonance. How does the particle actually move and behave within this dimensional space?
And that realization leads us directly to the third and final axis of the charge triad, the V sub dir.
The vibration direction.
Yes, the vibration direction.
Axis number 3, the motor. Let's dig in. How does the motor work?
Well, if the spin director is the compass pointing the way, the vibration direction is the internal oscillation axis of the resonance itself.
Okay.
You have to remember, every single particle in this lattice is vibrating. Reality is a constant state of oscillation. But this vibration isn't random static. It has a very specific geometric preference.
And this vibration preference dictates how the particle moves between those dimensional tiers, right? Like how it aggressively oscillates back and forth between D0 and D2.
Yes, and how it oscillates determines absolutely everything about its physical stability. If the internal vibration aligns with the psi branch.
And remember, psi represents contraction and inward curvature.
Right. If it aligns with psi I,
Yeah.
then the oscillation is incredibly smooth, it contracts tightly, it stays highly stable, and it remains safely and predictably confined to bouncing harmlessly between D0 and D2.
Okay, but what if the motor aligns with phi, the expanding branch?
If the vibration aligns with phi, the oscillation becomes inherently erratic. It wants to expand outwards, but it's constrained. Dukas describes this state mathematically as becoming torsional.
Torsional, like it twists.
It twists, it strains, it loses that tight, safe confinement.
So hold on, is it kind of like a figure skater? I'm trying to picture the mechanics of spinning and expanding.
Okay, let's hear it.
If the spin director is the skater mentally deciding they're going to execute a spin, they set their internal compass.
Right.
The dimensional polarity, the second axis, is the ice rink itself. It's the polarized environment they have to perform in.
Okay, I like where this visual is going. It incorporates the environment.
But the vibration direction, this third axis, is what the skater does with their physical body to execute and maintain the spin. If they pull their arms incredibly tight to their chest.
Which represents aligning with psi, that inward contraction.
Exactly. They spin smoothly, incredibly fast, and with perfect stability. They are locked to that one spot on the ice.
Right.
But if they suddenly throw their arms wide open, aligning with phi, outward expansion, they immediately lose control.
They do.
Their center of gravity shifts, they start flailing, the spin becomes torsional and chaotic, and they are probably going to crash into the boards.
If we connect this to the bigger picture, that figure skater analogy is exceptionally accurate.
Mm.
And it's not just useful for explaining standard particles like electrons.
What else does it explain?
It becomes incredibly powerful when we look at the messy parts of the particle zoo, specifically when we look at fractional charges.
Oh, right. The paper spent a significant amount of time talking about quarks, and standard physics has always made quarks sound completely illogical.
Think about quarks for a moment. In the standard model of particle physics, quarks have these incredibly weird, messy fractional charges.
Yeah, up quarks have a charge of positive 2/3. Down quarks have a charge of negative 1/3.
Right. And if you operate under the classical model, the one where charge is a fluid substance, it's mathematically and philosophically really hard to explain why a fundamental, indivisible particle would inexplicably carry exactly 1/3 of a fluid.
It sounds like a bad baking recipe. Just add 1/3 of a cup of negative charge fluid to the batter.
Right.
Where is the rest of the fluid? Why is it broken into thirds? It makes no sense if it's a substance.
It's one of the glaring awkwardnesses of the standard model.
Mm.
But in TDUFT, using your figure skater analogy, fractional charges suddenly make perfect, elegant geometric sense. Quarks simply have a vibration direction and a spin director that don't fully align perfectly with either the pure phi or pure psi branches. They are partially oriented.
So it's like a figure skater leaning at a really awkward 45-degree angle while trying to spin.
Yes.
They aren't fully upright, perfectly perpendicular to the ice, but they aren't totally fallen over horizontally either. They are locked in a partial state of orientation.
Yes, exactly. And the math in Ducas's paper specifically shows that the calculations of the charge triad operator naturally allow for these partial geometric projections.
Oh, wow.
It's just vector math. If you draw an arrow pointing diagonally, a fraction of that arrow's length projects onto the horizontal axis, and a fraction projects onto the vertical axis.
That makes total sense.
That fractional projection onto the psi axis is what we physically measure as a fractional charge. It's not a fraction of a magical substance. It's quite literally a fraction of an angle.
That is deeply satisfying. Honestly, it just cleans up the messy duct tape nature of the standard model so elegantly.
It really does.
You don't have to invent a new rule for why quarks are weird. They just point in the different direction.
Precisely.
Okay, so we now have the complete identity of charge. The compass, the map, the motor, the three axes multiplied together give us the geometric orientation.
Right.
But here is the massive, unavoidable question I was left with after reading this section. How does a geometric orientation, which, as we've established, is just a set of mathematical vectors dancing between dimension 0 and dimension 2, how does that give us something we can actually touch? How do we measure it? How does a geometric angle give us mass?
And this is where TDUFT makes its most radical, arguably controversial leap. Chapters 9 and 11 of the source text are entirely devoted to deriving mass.
Okay.
In this theoretical framework, mass is not an inherent property of a particle.
Okay, pause. Say that again, because that completely breaks how we view the physical world.
Mass is not an inherent property. It is not something the particle has intrinsically the way you have blood in your veins.
Then what is it?
Mass is a shadow. Specifically, Dukas defines it as a shadow projection cast from the third dimension, D3.
Here's where it gets really interesting. I want to make sure I'm getting this mechanical concept right, because it took me a few reads to grasp how counterintuitive it is.
It's definitely a brain bender.
Particles, like the electron, they never actually enter the third dimension. Is that correct?
Mm-hmm.
The things making up my solid computer desk are not actually in the third dimension.
That is mathematically correct within this theory. They're absolutely locked into oscillating between D0 and D2. The math proves that a stable psi-aligned electron mathematically cannot elevate into D3.
Wow.
The energy requirements and geometric constraints forbid it.
Oh, wait, I have to push back here. We live in a 3D world. I can weigh an object on a scale. I can measure the mass of an electron in a particle accelerator.
Right.
If the electron itself is permanently stuck in 2D space, how does it interact with our 3D instruments? This feels like a magic trick.
It's an excellent pushback, and it's the exact hurdle peer reviewers will throw at this theory. But Dukas anticipates this.
Okay.
The interaction happens through the D3 mass projection operator. Even though the electron is confined to D2, the geometric structure of the third dimension projects downward onto that 2D resonance.
Okay, explain the math behind that projection, because formulas without context usually lose me.
Dukas gives the fundamental formula for mass as m equals d cubed times t squared.
M equals d cubed times t squared.
The d cubed represents the three-dimensional space operator. But the t squared is the crucial part. It represents the temporal variance, or the specific internal torsional period of the resonance.
So mass isn't a solid block.
No, mass is the result of three-dimensional space interacting with the vibrational timing of a two-dimensional particle.
I was trying to come up with a visual for this projection, and I have to use a shadow puppet analogy here to try and map this out.
Really, the shadow puppets.
Imagine a classic shadow puppet theater. You have a solid wall, you have a bright light source shining directly on the wall, and you have your hand making a shape in the empty space between the light and the wall.
Okay, let's map the mathematical variables to your theater.
Your hand is the particle. It exists in the space between the light and the wall. Let's call that intermediate space D2.
Right.
Your hand is doing its dance, it's oscillating, vibrating, making shapes. The wall is the third dimension, our physical, observable, everyday reality, where we measure things like weight, momentum, and mass.
And the shadow cast on the wall.
The shadow is what we measure as mass. Your hand never actually physically touches the wall. The electron never enters D3. But the light, the projection operator from the higher dimension, casts the shadow of your hand onto the wall.
It's brilliant.
If your hand makes a tight, solid fist, like a psi-aligned, highly stable electron, it casts a very dark, sharp, permanent shadow on the wall. That dense shadow is what our 3D instruments measure as the mass of the electron.
That analogy works exceptionally well, specifically because it highlights the indirect nature of measurement.
Right.
What's fascinating here is how flawlessly that aligns with the deep mathematics of the theory. Dukas explains that the pure foundational geometric structure of a particle comes from what he calls the universe equation.
Right. The golden ratio equation. Phi squared minus phi minus 1 equals 0. I was amazed to see that pop up.
It is stunning. The equation phi squared minus phi minus 1 equals 0 is the mathematical definition of the golden ratio.
Which is found everywhere.
Everywhere in nature, from spiral galaxies to the arrangement of leaves on a stem. In TDUFT, this equation represents a structural geometric zero. It's pure math. It has absolutely no physical weight or mass on its own.
Okay.
But the shadow operator, the light in your analogy, acts on that pure geometric zero and translates it into physical, measurable mass.
It literally turns pure math into physical matter.
Yes. And to ensure the mass doesn't break down, Dukas outlines a damping series. In simple terms, think of it as a set of mathematical shock absorbers.
Shock absorbers, okay.
These shock absorbers ensure that the shadow cast on the wall is a finite, stable, measurable value, not some infinite, blurry mess that takes up the whole wall. It calibrates perfectly to the known, experimentally measured mass of the electron.
It turns math into matter. Just let that sink in for a second if you're listening.
It's wild.
When you push against a heavy door, you aren't pushing against stuff. You are pushing against geometric shadows cast by higher dimensions. It completely reframes reality.
It really does.
Okay, so if mass is just a shadow and the shape and density of that shadow are governed by our charge triad, the hand making the puppet, what happens when the triad casts a chaotic shadow instead of a clean, sharp fist?
That question is perhaps the most profound in the entire paper. It brings us to the very reason you and I are sitting here today, breathing and talking, instead of being irradiated into oblivion.
Right.
It explains why half of the potential matter in the early universe instantly destroyed itself. It explains the concept of stability asymmetry.
The cosmic battle between the electron and the positron, why matter won and why we exist. Standard physics calls this the matter-antimatter asymmetry problem, right?
Yes, the baryogenesis problem. In the standard model, the Big Bang should have created equal amounts of matter and antimatter.
But they destroy each other.
Exactly. And since matter and antimatter annihilate each other on contact, the universe should be entirely empty, filled only with leftover light.
But we're here.
We are here. The standard model has to invent very complex, unproven mechanisms called C-key violation to explain why matter survived. TDUFT doesn't have to invent anything. It explains it purely through geometry.
Let's walk through that geometry. Let's review the electron first. We know it has a negative charge. In TDUFT terms, that means its triad is psi-dominant. It aligns with contraction.
Right.
When the D3 light shines on a psi-dominant resonance, it creates a contraction shadow.
The tight, solid fist in your puppet theater analogy.
Right. It locks the electrons safely into that D0 to D2 cycle.
And the mathematical proof is in what we call eigenvalues. Now, to translate that from math jargon, an eigenvalue is basically a scaling multiplier.
A multiplier, okay.
If a process has an eigenvalue less than 1, it means every time the cycle repeats, the energy shrinks, it dampens, it stabilizes.
It gets smaller.
Right. The electron's psi-dominant geometry produces an eigenvalue of less than 1. This means any perturbations, any external bumps or jostles naturally shrink back to 0.
It self-corrects.
It is perfectly self-correctingly stable. It physically cannot spike into D3. This absolute confinement is why electrons are essentially immortal. They never decay.
Okay, I understand why the electron is a survivor. But what about its so-called evil twin, the positron? Why is antimatter doomed?
The positron is where the theory shows its immense predictive power. The positron shares the exact same geometric core as the electron.
Okay.
It is built from the exact same golden ratio universe equation. It has the exact same theoretical mass equation.
But it has a positive charge.
Exactly. Its triad is phi-aligned. It aligns with expansion.
So going back to the ice rink, the skater has thrown their arms wide open while trying to spin at maximum speed.
Yes. And because it aligns with expansion and outward curvature, the scaling multiplier, the eigenvalue, is greater than 1.
Meaning every time the cycle repeats, the energy multiplies and grows. It doesn't dampen.
Precisely. Perturbations grow exponentially. The shadow it casts is not tight and sharp. The paper describes it as a diffuse, torsional projection.
So the shadow on the wall is fuzzy, wildly vibrating, and constantly growing in size.
And because it is expanding and vibrating wildly, it fundamentally loses its dimensional confinement. The positron cannot stay locked safely in D2. The outward torsion physically forces it to spike up into D3.
It reaches out and actually touches the wall.
It crashes violently into the wall. And when a low-dimensional resonance forcefully spikes into a higher dimension that its underlying geometry cannot sustain, the shadow collapses.
Oh, wow.
The structural integrity fails. The particle annihilates, releasing all its stored geometric potential as raw energy.
So positrons aren't inherently evil twins of electrons made of some opposite, spooky anti-substance.
Not at all.
They're literally just mathematically prone to spinning out of control and crashing into the third dimension simply because they leaned the wrong way.
If we connect this to the bigger picture, this is the elegant geometric solution to the matter-antimatter asymmetry puzzle. Why is the universe made of matter? Because charge is not just a plus or minus sign tacked onto a particle.
It's a stability operator.
It is a literal stability operator. Negative charge equals inward stability. Positive charge equals outward instability.
So cool.
The universe is made of electrons because psi geometry survives the mathematics of dimensions. Positrons destroy themselves because phi geometry is inherently unstable.
It's survival of the geometrically fittest. The universe is just biased towards contraction because contraction doesn't spontaneously explode.
Exactly.
That completely rewires how I think about antimatter. Okay, so we've solved the electron and the positron. We understand why negative is stable and positive is doomed. But the universe isn't just electrons bouncing around. What about the rest of the particle zoo? What about things that have absolutely no charge at all? How does a compass orientation explain a particle with no direction?
Well, TDUFT doesn't ignore the rest of the particle zoo. It actually categorizes them beautifully based entirely on their composite geometric orientation vectors. Let's look at the photon, the fundamental particle of light.
Right. Light has no mass, and it has 0 electrical charge. How does it fit on a polarized dimensional highway?
In TDUFT, a photon is neutral because its charge triad is orthogonal. It's perfectly balanced.
Unique.
It doesn't lean into the phi branch, and it doesn't lean into the psi branch.
So it's standing perfectly straight up on the ice, not leaning in, not leaning out.
Exactly. And because it has absolutely no branch dominance, the D3 mass projection operator, the light casting the shadow, has nothing to catch on to.
So no shadow?
It casts no shadow on the wall in its ground state. And as we established, no shadow means no measurable mass.
Okay, but wait. Let me pull up my notes here. The paper specifically states that photons can have mass, at least temporarily. How does something with no shadow suddenly gain weight?
Yes, during highly energetic events, what the paper formally calls D2 to D3 spiking, the photon can get temporarily knocked out of its perfect balance.
Oh, it wobbles.
It absorbs massive energy and it acquires torsion. It starts to twist. When that happens, it briefly casts a torsion shadow, which gives it an emergent, incredibly short-lived effective mass.
Got it.
But as soon as the energy dissipates, the spike ends, the
Mm.
shadow vanishes, and it's completely massless again.
It's like the hand making the puppet moves too fast, briefly blurs, casts a weird thick shadow on the wall for a millisecond, and then goes back to being invisible when it stops moving.
That's a great visual.
That makes perfect sense. Okay, what about the heavy hitters? The baryons, protons and neutrons, the actual stuff that makes up the nucleus of atoms, the stuff that makes up our bodies.
Protons and neutrons are what we call composite charges. They are not single, pure resonances like an electron. They're made of 3 quarks each.
And we established earlier that quarks are the figure skaters leaning at awkward 45-degree fractional angles, right?
Right. So to figure out if a proton is stable, you don't need a new set of physical laws. You just do the vector math.
You just add them up.
You add up the geometric orientations of the 3 quarks. A proton has 2 up quarks, which broadly lean toward the expanding phi branch, and 1 down quark, which leans toward the contracting psi branch.
But it sounds unstable. That's 2 expanding against 1 contracting.
You'd think so intuitively, but when you do the actual tensor math and sum their specific vibration geometries together, the overall composite triad of the proton ends up being mathematically psi-dominant.
So even though there are expanding explosive parts inside it, the total combined sum is inward and contracting. It's a sturdy tripod. It balances itself out.
You're on the right track with the result, but be careful with the tripod visual, because it's less about a physical, rigid structure and more about canceling out conflicting wave frequencies.
Oh, like noise-canceling headphones.
Exactly. It's destructive and constructive interference. The overall wave vector sums to an inward, contracting, stable vibration direction. That's precisely why protons are incredibly stable and don't decay.
Incredible.
But compare that mathematical harmony to a meson.
Mesons are those highly unstable particles that exist for fractions of a second in particle accelerators. A meson is just a quark and an antiquark paired together, right?
Yes. And because one is matter and one is antimatter, they have violently opposing phi and psi vectors. One is pulling aggressively outward, the other is pulling aggressively inward.
It's a fundamental tug of war.
A tug of war that always ends in a snapped rope.
Mm-hmm.
The composite vibration direction rapidly expands, the torsion increases exponentially, and they rapidly decay into a shower of other particles. TDUFT doesn't have to invent new parameters or mysterious fundamental forces here to explain this instability. It perfectly matches the known standard model behaviors purely through these allowed geometric angles.
It really is just adding up the arrows. If the arrows point in, you get a proton and you get a stable universe. If the arrows point out, you get a positron or a meson and you get a microscopic explosion.
That's the essence of it, yeah.
And I have to mention, the paper even touches on dark photons, which I thought was fascinating.
Yes, dark matter is one of the biggest embarrassments in modern cosmology. We know there is extra mass in the universe, but you can't see it.
Right.
Dukas suggests dark photon candidates are essentially resonances with an orthogonal spin director, exactly like a regular photon, but with a mixed vibration direction that severely suppresses the mass shadow.
So it's casting a shadow, but the shadow is so pale, so incredibly transparent that it barely registers on our instruments.
Precisely. They cast a geometric projection so minimal it barely interacts with any other matter.
Yeah.
Near zero electrical charge, near zero mass. It geometrically explains why dark matter is so dark and so incredibly hard to interact with. It's just casting a very weak shadow.
This raises an important question, though, or rather, it brings us to the ultimate question underlying everything we've talked about.
Okay.
All these elegant vectors, the dimensional compasses, the mass shadows, the intricate steps of the D ladder. It's a breathtakingly beautiful machine. But what is the engine driving the machine?
The fuel.
Yeah, why does the field contract and expand in the first place? What is the actual fuel making the geometry vibrate?
That is the philosophical and physical climax of the entire paper. It's the combination of Dukas's work. The fundamental engine of reality in TDUFT is a concept called bidirectional entropy.
Bidirectional entropy. I'm going to need some serious translation here because standard entropy usually only goes one way, right? The second law of thermodynamics. Things get messier. The hot coffee cools down, the dropped coffee cup shatters. It doesn't spontaneously unshatter and jump back into your hand. Arrow of time, all that.
Classical thermodynamics teaches us about outward entropy, yes. The relentless march toward disorder. And that absolutely exists in TDUFT.
So where does it fit in?
Outward entropy is what drives the infinite geometric expansion of the phi lattice. It is the creative, explosive force that builds the infinite dimensional ladder. It pushes outward, creating space, volume, and potential.
But if there was only outward entropy, if everything just relentlessly expanded, wouldn't the universe just be a rapidly expanding, chaotic soup of infinite dimensions?
It would be.
Nothing solid could ever form, right?
Precisely. An engine running only on outward expansion just blows itself apart, which is why Dukas introduces the necessary mathematically required counterforce, inward entropy.
How does entropy go inward? How do things naturally tend toward order?
It manifests mathematically as convergent damping. The paper heavily references a harmonic attenuation series.
Okay, those mathematical shock absorbers again.
Exactly. Remember those from when we were discussing the shadow? This is the fundamental, universe-wide geometrical force that suppresses higher modes of vibration. It literally forces infinite expanding sequences to converge down to a finite, manageable point.
So what does this all mean for our little hero of the story, the humble electron?
The electron sits perfectly, miraculously balanced in the absolute crossfire of this bidirectional flow.
Caught in the middle.
Because the inward damping series converges, absolutely, remember, the mathematical eigenvalue of psi is less than 1. So it relentlessly shrinks any excess energy down to a point. The infinitely expanding outward lattice is forced to produce a finite, measurable mass.
I am really trying to visualize bidirectional entropy. Is it like a river that somehow flows in two opposite directions at the exact same time?
That's a bit tough to picture. Think of it more like a massive ancient oak tree.
Okay, a tree.
The outward entropy is represented by the branches. They infinitely split, reaching outward, expanding upward toward the sun, constantly creating more and more complex fractal structures in the canopy.
Reaching out and creating the dimensions, the D ladder.
Right. But the tree cannot survive. It cannot support that structure without its roots. The roots pull water and nutrients inward, converging from a vast, sprawling area deep underground, pulling it all into a single, solid, finite trunk.
That makes perfect sense.
That massive convergence is the inward entropy. The physical particle we see, the electron we measure in our laboratories, is the trunk of the tree. It is the solid, finite node where the infinite outward reach of the branches and the infinite inward pull of the roots perfectly harmoniously balance.
In the charge triad, whether the particle leans toward phi or psi, whether it's an electron or a positron, is simply the physical signature of how that specific particle is handling this bidirectional flow. If its geometry leans toward the roots, it's an electron and it forms a solid trunk. If it leans entirely toward the branches, it's a positron, it loses its footing and it flies apart into the canopy.
You've got it. You've grasped the core of PDUFT. The entire architecture of charge, mass, and matter rests on this profound cosmic duality.
Infinite structure and finite emergence, coexisting and creating reality through the engine of bidirectional entropy.
Beautifully said.
So, matter as we know it, the very fact that we have bodies and planets and stars, is quite literally just the mathematical survivor of this process.
It is.
That completely changes how I look at everyday objects. Let's take a breath and really recap the incredible journey we've just been on. Because we started an hour ago in a high school physics class looking at little red and blue painted spheres.
And we have somehow ended up in a fractal forest driven by bidirectional entropy.
It requires a complete rewiring of how we visualize the quantum world. But once you see the geometry, the messy parts of physics suddenly snap into elegant focus.
They really do.
So let's lay it out one last time, clearly and cleanly. Charge is not a substance. It's not a fluid. It is purely a geometric orientation.
Yes.
It is the spin director pointing the dimensional compass, the dimensional polarity providing the polarized map, and the vibration direction acting as the motor determining how it oscillates.
That is the triad.
Mass is not a solid intrinsic object. It is a shadow, a literal projection cast from the third dimension down onto a particle that is locked in a frantic, vibrating oscillation between dimension 0 and dimension 2.
A shadow calibrated precisely by the golden ratio universe equation.
And absolutely everything. The stability of the matter making up our bodies, the violent death of antimatter, the very emergence of mass itself is driven by the deep cosmic breath of bidirectional entropy.
The phi expanding outward into infinity and the psi pulling inward to create finite reality.
It is a theory of profound geometric elegance. It removes the arbitrary magic numbers and inexplicable fluid fractions from particle physics and replaces them with pure, mathematically sound structure.
It really does. It's a whole new paradigm.
But before we sign off, I want to leave you, the listener, with one final, deeply provocative thought. Something that wasn't explicitly spelled out in the math today, but is heavily, heavily implied by the text.
Ooh, this is a good one.
Dukas notes that extreme, catastrophic environmental conditions could theoretically alter a particle's charge orientation. It could physically mess with the compass, which would thus alter its mass shadow.
That is a very tantalizing and slightly terrifying prediction.
So if charge and mass are just geometric shadows cast by our specific dimensional alignment, what happens to the matter in our universe when it crosses the event horizon of a black hole?
The ultimate extreme environment.
Does the extreme, theoretically infinite gravity warp the ice of the Phi field so severely that the electrons are literally forced to change their vibration direction?
Do they shift their spin directors?
Yeah, do they stop casting three-dimensional mass shadows entirely and become something completely new, something beyond D3?
It's entirely possible under this framework.
Keep that in mind the next time you look up at the stars and realize that everything you see, everything you touch, is just a beautiful mathematical shadow of a much deeper geometry. Thank you so much for joining us on this deep dive.